Hello all, this is Mr. G, and in this video we're going to go over a review of graphing, writing, and describing quadratic functions. Let's not waste any time, let's jump right in. Here's number one. It says graph each function. So the first section we're graphing, number one is f of x equals 2 times the quantity x plus 3 squared minus 8. Now, when I look at this, the first thing I see is this is in vertex form. So let's remind ourselves what vertex form is. It's f of x equals a times x minus h squared plus k. Now, whenever we're graphing a parabola, and we know this is going to be a parabola because we see the highest power of 2 for our variable, that means it's a quadratic. Whenever we're graphing a parabola, the first thing is always to find the vertex, which is hk. So for this one, h is going to be a negative 3 because it looks like a positive 3, but remember, in the original formula, it's a negative h. So whatever, how do I want to say this? Whatever sign it looks like h is, we change the sign when we take it out of the equation or out of the function rule. So it becomes a negative 3 and negative 8 for k because k stays the same. So negative 3, negative 8, let's graph that vertex. Negative 3 and negative 8 would be right there. Tell you what, I'm going to circle that in a different color just to emphasize that that's the vertex. It's the most important point. We could even draw the axis of symmetry through it as well. You don't need the axis of symmetry, like it's not part of the answer, but having it there could be helpful. Okay, vertex is done. Now, the only thing we have not used from our equation, we've used h and k, so we're missing the a value, which is 2. So a equals 2. And A gets us to our next point. So we start at the vertex. We always go right 1. So I'm going to, let's make another point. I'm going to go right 1 and then up or down whatever A is. A is a positive 2, so I go up 2, and there we go. And we can also rotate that over. It's one step away from the axis of symmetry. So one step away from the axis, so we go one step in the opposite direction, and we have our third point. Now we just need 2 more points. Remember, we always want 5 when we're graphing a quadratic. And we're all pretty much done with vertex form. Like there's nothing left in vertex form that's going to help us. So here we just need to pick another x value and plug it in. Now we could pick any x value we want, but the best x value is going to be right here or right there. Basically, we want to go one more step away from the vertex. I usually end up going one to the right. So our vertex was right here. We moved over 1 for our a value. Let's move over 1 more and choose that as our x value to plug in. So that's an x value of negative 1. So our new point is going to be negative 1 something. And to find that something, to find whatever the y value is, we got to substitute in. We got to plug in that negative 1 into our vertex form. So it becomes f of negative 1 equals, let's see, it's 2. Okay, I can get it all on the screen at once. So it's 2 times, instead of x, we write negative 1, substituting that in, plus 3 squared minus 8. Now, I want to emphasize, we could have picked any x value we want. The reason I like to pick numbers that are close to the vertex, though, is because the further away, or excuse me, the farther away we get from the vertex, the more likely we are to get a y value that's way off of our graph, either way too high or way too low. All right, so enough of my talking. Let's go back here. So it becomes f of negative 1 equals, now it's just a PEMDAS problem. So it becomes 2 times, let's think, negative 1 plus 3, that's a positive 2 squared minus 8. And let's see, this becomes, now we're going to do the exponent next. So we're not going to multiply, we're doing the exponent. So 2 squared becomes 4, so we get 2 times 4 minus 8. And then this becomes 2 times 4 is 8, minus 8, and we get 0. So the point is negative 1, 0. So it's right there. And then we can do another one, just fold it, excuse me, not fold, but reflect rather. Let me get another point. Reflect it over the x-axis, not the x-axis, reflect over the axis of symmetry. Let me do that one more time. So it's 2 steps away from the axis of symmetry, so we go 2 more steps on the other side of the axis of symmetry, that line of reflection that we can fold our parabola over. And then we just draw it in. So we've got a parabola right there, and we finish the other side right there. Now, obviously, the curve I've drawn is not like exactly perfect, but we've got 5 good points. We've got the vertex, these 2 points, and those 2 points. So that's good enough for our graph. So we've graphed it, and we can check our answer just to make sure I didn't make a mistake. That looks pretty good to me. All right, 1 down. Let's take a look at number 2. Same directions. And looking at this, immediately I recognize this as vertex form because we have sort of this x in parentheses with another number and squaring it. So let's write our vertex form. So it's a times x minus h squared plus k. And we're going to approach this just like we did number one, since it's another vertex form problem. That means we need to find the vertex first, which is hk. You don't need to write that down. You don't need to write down hk every time. I'm just sort of showing my work. H would be a -1, and k is a +8. So we graph -1 and 8. So that is our vertex. We'll circle it to emphasize it, and we'll draw our axis of symmetry. Remember, axis of symmetry, not part of the final answer, but it's important to have. There's the vertex emphasizing. Okay, next up is the a value, which is -3/4. A equals -3/4. Now, even though this is a fraction, we're going to start at the vertex. We always go right one, and then we go up or down, whatever a is. Since a is -3/4, we go down. Let's see, that might be down a half, so down a little bit more for a 3/4. It's not going to be perfect, but as long as it's reasonably close, that's good enough for our purposes. We reflect our next point over the axis of symmetry, and we've got 3 points, just need 2 more. Now, to get our fourth and fifth points, we just choose an x value. So we already had the vertex right here. We moved over 1 for the a value. So move over one more time. This is the x value we want to pick. So we want to pick an x value of 1. At least that's the one I would pick. You could pick any x value. I think 1 will be the easiest to use in this case. Now we just plug it in. So it becomes f of 1 equals, what was the original function? -3/4 times, we substitute 1 for x, keep copying, plus 1 squared, plus 8. And then we simplify with the order of operations. So this becomes -3/4 times 1 plus 1 is 2 squared, plus 8 comes down, equals -3/4. We have to do our exponent first. 2 squared becomes 4, plus 8. Let me see. We could do this a few different ways, multiplying here. I'm just going to cross cancel. The 4s are going to cancel out, so they just become 1s. It becomes a -3 plus 8, and we get a 5. That's not the only way to simplify that, but in my mind, that's the easiest way to do it, at least to do it mentally in my head. So the point was 1, 5. We plugged in an x value of 1, got a y value of 5 out. So we graph that point. So 1, 5 is right here. And we can do the same thing with another point. So of course they copied like that. That's what I meant to happen. So this other point is 1, 2 away from the line of symmetry, 1, 2 away on the other side. Line of symmetry, axis of symmetry, essentially the same thing. And then we graph our parabola and check our answer. Looks good to me. Let's take a look at number 3. Now, right off the bat, we can see the directions are the same. It says graph each function, but this is a very different type of problem than we saw in numbers 1 and 2. Numbers 1 and 2 were given to us in vertex form, but this equation is in standard form. So we have to remember that standard form is y equals ax squared plus bx plus c. Now, there are some advantages and some disadvantages of standard form. And the big disadvantage, unfortunately, is that it's a lot harder to find the vertex when we're in standard form. In vertex form, we just find h, find k, and that's the vertex. But in standard form, we have to remember the formula -b/2a. So hopefully we have that memorized. And we have to remember what that's going to give us. That's going to give us not the entire vertex, but just the x-coordinate of the vertex. So we got a little work to do. Let's jump right in. So -b/2a, for this, that's going to be, let's see, b is a -4, so negative b would then be a minus a -4, which becomes a +4. 2 negatives make a positive, like that. And then 2a would be 2 times 2/3. Then we just simplify. Let me see. So we get 4 divided by, that's going to be 4/3, which essentially is like a 4 divided by 4/3, which we can then write as 4 times 3/4. Then we can cross cancel, those 4's go away, and we're left with 3. So 3 is the x-coordinate of the vertex. So we know the vertex is going to be 3 something. Actually, let's write that down here. I think that's going to be better down here. The vertex is going to be 3 something. Now, to find the y-coordinate, we just have to take our x and plug it in. We can always plug in an x to find the y that corresponds to it. So we end up with y equals 2/3, and it was, 2/3 x squared. So that becomes 2/3 times 3 squared minus 4x becomes -4 times 3. and then plus 3. I actually don't like that this work is on the graph, so I'm going to take this and slide it down just so we don't mess up the rest of this problem. Now we just simplify. So we get y equals 2/3. We do our exponents first. 3 squared becomes 9, minus 4 times 3 is 12, plus 3. Let's keep going. So 2/3 times 9, we can cross cancel. The 3 and the 9 are both divisible by 3. The 3 becomes a 1. The 9 divided by 3 is 3. 2 times 3 is 6. Now, that's not the only way to simplify that multiplication. If you'd rather use a calculator or convert to a decimal or something like that, I guess you could do that. I think cross-canceling is the easiest way, but what's best for me might not be best for you. As long as you get 6, we're good. Let's keep on going. So minus 12 plus 3. And let me think about this. 6 plus 3 would be 9. And 9 and negative 12 would be negative 3, if I'm doing that correctly ahead. I think I am. Let me double check myself. 6 take away 12 is negative 6, plus 3 is negative 3. Good. And we take that and plug that back into our vertex. So we found our vertex, which is 3, negative 3. 3, negative 3. All right. And again, I'm going to highlight that as the most important point, the vertex, and we can even draw the axis of symmetry through if we want to. Remember, axis of symmetry is not a part of the final answer, but it helps us find the final answer. Okay, so that's the big disadvantage of standard form. It takes a lot longer to find the vertex, but once we find the vertex, I think standard form becomes a lot better because the rest of it is a lot easier, in my opinion. First of all, the A value works exactly the same whether we're in vertex form or standard form. Since it's 2/3, we're going to start from the vertex, go right 1, and then up 2/3. So up 2/3 might be about there, maybe a little bit more than halfway. And we do the same thing the other way, reflect over the axis of symmetry, the line of symmetry. Fill that in a bit better. There we go. And if this were vertex form, at this point we'd have to find an x and plug it in. So we would think, okay, we just did this x value at the vertex, we moved 1 over, so we'd have to move 1 over 1 time. Okay, take that by, plug it in. But with standard form, we can skip that entirely. Because in standard form, one of the big advantages is this form gives us the y-intercept if we know where to look. Hopefully we remember, why does it keep doing that? Hopefully we remember that C is always the y-intercept. So our y-intercept will be 3, or we could write it 0, 3. So I scroll down, we go to 0, 3. And then we can just do the same thing with another point. So let me draw another point up here, drag it down. So we reflect it over the x-axis, 1, 2, 3 steps away, 1, 2, 3 steps away. Remember, that's what's so beautiful about that line of symmetry, that axis of symmetry. Any point we find, we can immediately double and get another point. Well, except the vertex, obviously, but anything besides the vertex, we can fold it over and we get another point. And we're done. Let's check our answer, just like we've been doing with the rest of these review problems. Let's take a look. So vertex is 3, negative 3. That looks good. A value looks good. And 1, 2, 3, 1, 2, 3. Yep, looks good to me. Let's take a look at the next one. Same directions. It says graph each function. Let me think. So vertex form or standard form, that's the big thing. Since I see those parentheses, I'm going to treat this like vertex form. So vertex form would be g of x, in this case g of x, a parentheses x minus h squared plus k. So we got to find our h and k for the vertex. H, it looks like a negative 5, so it comes out as a positive 5. And our k value, there is no number being added or subtracted at the end, so that means k is 0. So 5, 0 is our vertex. Let's graph it. 5, 0. And after finding a vertex in standard form, once it's in vertex form, hopefully it's very obvious if it wasn't already, that vertex form is a lot, or when we're in vertex form, it's a lot easier to find the vertex, hence the name. See what we did there? Okay, let's keep going. Where were we? Found the vertex. Now we have to use our a value, which is a negative 1. So a equals negative 1. Let me show my work and not be lazy. So we start at the vertex, and we know how the a value works. We always go right 1 and then up or down whatever a is. Since it's a negative 1, we go down 1. Didn't mean to right click, just go down 1. There we go. And we'll do the same thing, or not the same thing, but we'll take that point and reflect it over the line of symmetry. I guess we could have done the same thing, like start at the vertex, go left 1, and then down 1 since a is negative 1. But I usually just think of it as a reflection folding over that line of symmetry. And now here's where vertex form is a little bit more annoying because we have to plug in a number. So our vertex was right there. We can go left or right. I guess I'll go right one, and then we need to go right one more. So we have to plug in an x value of 7. So our new point is going to be 7 something, and it's our job to plug in x and find it. So this becomes g of 7 equals negative 7 minus 5 squared. And we simplify. That becomes, let's do parentheses first. 7 minus 5 is 2 squared, and we just get negative 4 when we square 2. 2 times 2 is negative 4. Remember, this negative, let me do this in a different color. This negative was not being squared, so we don't do negative 2 times negative 2. It's just 2 times 2, and then we put a negative in front. So what's our point? 7, negative 4. Go to 7, and then 1, 2, 3, negative 4 right there. That's our first point, and then we do what we've been doing all video long. We take that point and fold it, 1, 2, 1, 2, fold it over the axis of symmetry, and then we draw our parabola to finish this out. Last but not least, let's check our answer, make sure we didn't make a mistake. Take a look there. So 5, 0 was the vertex, looks good. A value's down 1, and then the other points are 1, 2, 3 away. Yep, looks good, looks good. All right, more graphing. Okay, h of x equals negative x squared plus 4x. Remember, first big decision is it vertex form? Is it standard form? I'm going to treat this one like standard form because that's the form it is. So that would be h of x equals, let me think standard form. That's ax squared plus bx plus c. Let's separate that. Okay. We know it's going to be more annoying to find the vertex, but we can find the vertex. We just have to remember negative b over 2a. That is the most important thing to remember about standard form. So anytime you have standard form, immediately you got to think negative b over 2a. Let's think. Negative b, that would be a negative 4, because b was a positive 4. And 2a, that would be 2 times our a values right there. That's a negative 1. 2 times negative 1. Then we simplify. We get negative 4 divided by 2 times negative 1 is negative 2. Negative divided by negative becomes positive. 4 divided by 2 becomes 2. We have to remember what that 2 represents. 2 is the x-coordinate of the vertex, not the entire vertex, just the x-coordinate. So the vertex is going to be 2 something. To find that something, to find that missing y value, we know what to do. Take that x value, to plug it in as a domain value, plug it in as an input. So the function becomes h of 2 equals, and can I see them both at the same time? I guess I can. It becomes negative x squared, and x is 2, plus 4 times x. So it becomes 4 times 2. And just like, I forget what problem, whatever problem it was, let's scroll this down just so we can keep our board work slightly more organized. So let's think. That becomes negative 2 times 2 is 4, plus 4 times 2 is 8. Negative 4 plus 8, that becomes a positive 4. So that's the y-coordinate of the vertex, which means the vertex is 2, 4. Let's graph it. 1, 2, and 4. There we go. Now, here's where standard form becomes easier than vertex form, because we just use our a value, which is a negative 1. So we go, put another point there, go right 1 and down 1. Oh, I didn't put my axis of symmetry. Again, even though it's not part of the answer, I like to draw it in just to emphasize what point the vertex is. So if I forgot to do that and didn't write it for the final answer, that's still a correct parabola, but I like to have it in there. It's just personal preference. What was I doing? A value. Did I do this correctly, or did I get distracted? Right 1 and down 1 for a. Good. So that's correct. And we'll fold it over 1 step away, 1 step away. Now, we could plug in a number, like we could plug in an x value of 4, but we don't need to do that with standard form because our c value is always the y-intercept. And our c value is nothing because, this is essentially like a plus 0. So that means the y-intercept is 0. So actually, the y-intercept is the origin, which would be right there. And then we do the same thing. We get another point and drag it down. I keep saying the same thing. We don't do the same thing. We fold it over. It's 1, 2 steps, 1, 2 steps. I guess I probably meant the same thing from the previous questions. There we go. Let's see what that looks like compared to our answer key. Vertex is 2, 4, looks good. A value looks good, and it hits the origin. Excellent. So far, so good. Moving right along. Not sure what happened there, but whatever. It's all good. Number 6. More graphing? Oh my gosh. Okay, we look at this. We see standard form. Y equals ax squared plus bx plus c. You don't have to write that down every time. I'm just sort of showing my thought process. To find the vertex, we know we have to do negative b over 2a. Let's see what that becomes. B is 6, so negative 6 would be negative b. And 2a, that's 2 times 3. So we get, I don't want to be on the graph, so I'll put this right here. That's negative 6 divided by 2 times 3 is 6. And we end up with negative 1. That's the x-coordinate of the vertex. We know how to find the y-coordinate. Just take our x and plug it in. The equation would become y equals 3x squared becomes negative 1 squared plus 6 times negative 1 minus 4. I'm just going to make sure I plug that in correctly. I think it's good. 3 times negative 1 squared plus 6 times negative 1 minus 4. Looks good. And again, I'm going to scroll this down just so I'm not writing on the graph. That is not what I wanted to happen. That's what I wanted to happen. There we go. And we just simplify. So let's see. 3 times negative 1. Well, negative 1 squared is just 1, so that's 3 times 1. Minus 6 minus 4, just multiplying 6 times negative 1 to get negative 6. And, well, we know 3 times 1, that's just 3. I guess I can skip that step. That's not that big a deal. And let's see. 3 minus 6 is negative 3. Minus 4 is negative 7. Did I do that correctly? I think I did. Yes. That's the y value of the vertex. So we finished our vertex. Negative 1, negative 7. Negative 1, negative 7 will be right there. And let's emphasize that that is the vertex. Draw in our axis of symmetry. Okay. And now we do our a value, just like always, to get our second and third point. What was the a value? The a value was 3. So we go right 1 and then up 3, since it's a positive 3. Start at the vertex. Right 1, up 1, 2, 3. And same thing on the other side. I don't know why I keep saying same thing. That's really annoying. I mean, we could start from the vertex and go left and then up 3. But I mean, just use the axis of symmetry. Fold it over one step away on one side, so one step away on the other side, and you've doubled your point. All right. Next up, this problem is going to be exceedingly annoying because normally with standard form, at this point we would just go to our y-intercept, our c value of negative 4, but we just graphed. Oh, I didn't want to get rid of c. We just graphed the y-intercept with the a value, which means to find our fourth and fifth points, we're going to have to plug in another x value. So this is sort of the worst of both worlds for standard form. One, it was hard to find the vertex, or at least more difficult to find the vertex. And we can't even use the y-intercept to give us our nice, easy fourth and fifth point. So we've got some more work to do. So let's see. This was our vertex, x value, moved over 1 for the a value, moved over 1 more. This is going to be the best x value to plug in. So let's plug in a 1. We could have gone left or right. I prefer to go right. So let me write this down here. So we're plugging in x value of 1. That's what I said, right? Yeah. So it's going to be 1 something. So I plug in that 1. It becomes y equals 3 times 1 squared. If you're good enough to skip some of these steps, that's a good thing. I'm just showing all my work. I don't want to lose anybody. 3 times 1 squared, 6 times 1, negative 4. Okay, good. I guess we can just fill this in right here. This won't be that big a deal. Well, 3 times 1 squared is 1. 3 times 1 is just 3. Plus 6 times 1 is 6. Minus 4. And this becomes, let's draw a line just to separate those two steps. 3 and 6 is 9. Take away 4 is 5. Did I do that correctly? I think I did. Yes. So the point is 1, 5. That actually wasn't too bad. 1, 5. That was quite a jump. So 1, 5. That would be 1, 5 right there. And then we get another point. We do what we've been doing the whole time. Use that axis of symmetry. 2 steps away, and now we graph it. This is a very thin parabola. Done graphing, we check against our answer key. So negative 1, negative 7, that was the vertex I got as well. And then it's right 1, up 3 for the a value. Good. And then what was that point? 1, 5. Let's see. 1, 1, 2, 3, 4, 5. Yep, looks good. Excellent. All right, finally done graphing. Jeez. So we don't have to graph anymore. Now we have to determine the vertex, axis of symmetry, maximum or minimum value, and domain and range of each function. All right. So we're going to approach a lot of this the same way. First things first, we got to find our vertex. This is in vertex form. And I mean, we could graph this to find all this information, but I mean, with like all these decimals, like we really don't want to deal with this. So here we're going to use sort of our understanding of what these values do and how they affect the parabola to sort of describe the parabola and what it looks like rather than actually get our exact points. But the vertex we can get pretty exactly. It's going to be, well, this is vertex form in case I forgot to say that. So we're looking for h and k. h is a positive 9.14. Remember, always change the value of what h looks like. Since h looks negative, we pull it out as a positive. But we don't need to do that with k, so the k value is positive 5.36. There's our vertex. All right, now we need the axis of symmetry. Now, remember, the axis of symmetry is always a vertical line going through the vertex. Since it's a vertical line, we have to start with x equals. Okay, we can't just put the number. If you don't put this x equals, you haven't actually described the axis of symmetry. So it's x equals, and we just take our x value right from the vertex. So it's x equals 9.14. Maximum or minimum value. Here, I like to worry about the concavity first. That always helps me. And we get that from our a value, and specifically the sign of the a value, whether it's positive or negative. Since our a value is negative, I know this is stupid, but this is really how I think of it. I think negative, oh, I think sad, so frowny face. So it's concave down. Since it's concave down, the vertex will be right there, which makes the vertex a maximum. So this parabola, this quadratic, will have a maximum value. And that maximum value will be the y value of the vertex, because that's as high as it gets. It doesn't go any higher than that. So the maximum value is 5.36. Now, last but not least, we just need to describe our domain and range. So the domain, well, for any quadratic, that's always, I'm always terrible at writing these infinity symbols. It's always negative infinity to positive infinity, writing it in interval notation. We read this as negative infinity to positive infinity. It's not a coordinate or anything like that. And then the range value, let's see. There's a maximum value, so it's going to be everything at that point and then below it. So that means we're going to start at negative infinity, and we're going to go all the way up. What was that maximum value? It was 5.36. And since we're actually getting to 5.36, we put a bracket to show that 5.36 is included in the set. Let's check our answers. Move this down. Let's see. So vertex looks good. Axis of symmetry, maximum looks good. Oh, I just wrote these differently here, but that's okay. Like negative infinity to positive infinity, that's the exact same thing as saying all reals or all real numbers. And this interval notation means exactly the same thing as saying all reals or all real numbers where y is less than or equal to 5.36. So that one's good. Let's keep on going. Scroll down some. Right there. Okay, same directions, just a new function. Fortunately, this is also in vertex form, which is going to make our lives a lot easier. Again, even though we've got all these crazy numbers in here, that doesn't matter. Like, we're not actually graphing here. So don't let these big numbers bully you. Don't let them walk up to you and take your lunch money. You can deal with this. So the vertex is going to be negative 202 and 175. Remember, change the value of the h, or excuse me, change the value of what it looks like h is. It looks like h is a positive 202, so it comes out as an h value of negative 202. Axis of symmetry, we know that's going to be x equals negative 202 because it's x equals the x value of the coordinate, or the x coordinate of the vertex, I should say. Maximum or minimum value. Here, I like to think about the concavity. First, our a value is positive. We think positive, yay, we're happy. So it's a smiley face, which means the vertex is down there. So this will have a minimum value. And the minimum value will be 175, getting that right from the y value of the vertex. Moving right along, domain. For a quadratic, the domain is always the same. It's from negative infinity to positive infinity, or you could say all real numbers, same thing. And the range here, we need to think. There's a minimum value, so basically it's 175 and up. 175 and up. So we're going to start at 175. So in interval notation, we need a bracket around 175 to show that that's our starting point, or rather 175 is included in the set, and it's going to go up forever. So it's from there to infinity. Let's take a look at the answers to check ourselves. Vertex looks good, axis of symmetry, minimum value, all reals, and all reals where y is greater than 175. Forgot to put my parentheses, but I'll close that there. Excellent. Keep on rolling. All right, same directions, but now it's not vertex form anymore. It's standard form, which means we've got sort of more work to do, unfortunately. So before we can find the vertex, we've got to do negative b over 2a. Let's see if I can fit this work over here. I'm hoping I can. So negative b over 2a, that's going to be a positive 12 divided by 2 times a. That's going to be 2 times 2 over 5. And that would be, let's think. So that's going to be 12 over 2 times 2/5 is 4 over 5. So this would be 12 divided by 4 over 5. Again, you can do this a lot faster on your own probably. I'm just showing all my steps. And then that would be 12 times the reciprocal, so 12 times 5 over 4. Treat that like a 12 over 1. Then I prefer to cross cancel. Like this 12 and 4, they're diagonal, and they have a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And then we just do 3 times 5 and get 15. If you've got another way to get that answer, that's awesome. So right away, we have our x-coordinate of the vertex. Now we got to find the y-coordinate, so we got to plug in. So tell you what, just to save some space, I mean, this is a video. I don't need to keep all this here. You can always go back if you need to see that work. So now we just take that 15 and plug it in. So it's 2 over 5 times 15 squared. I guess technically I should have g of 15 here equals 2/5 times 15 squared minus 12 times 15 minus 17. I'm going to break out the calculator for this one because I really don't feel like making a mental mistake with this. So that's going to be 2 over 5 times, I believe this is 225, but I really don't want to screw this up, 15 squared. 225, good. Minus 12 times 15, let's think. That's 120 and, is it 180? 12 times 15, 180, good. And then minus 17. And again, we can just cross cancel here because 5 and the 225, they have a common factor of 5. So divide by 5, or 5 divided by 5 is 1. And then 225 divided by 5, that would be 45. I will double check myself after I finish this. So then 2 times 45 would be 90. So let me double check. So 2 divided by 5 times 225. Okay, that's not what I want. 2 over 5 times 225. 90. I think I did it faster in my head. I can't even work the calculator. Minus 180 minus 17. Let me think. So 90 minus 180, that's going to be a negative 90. Minus 17 is a negative 107. I'm double checking myself. I really don't feel like screwing this problem up. 90 minus 180 minus 17. Okay, negative 107. So we're good. Negative 1 over 7. And just to keep the board work, or rather this slide a little neater, I'm going to erase this work now. You can always go back if you want to look at it one more time. All right, axis of symmetry. Now, the beautiful thing now that we have our vertex is the rest of it is just like vertex form. So the axis of symmetry, we know that's x equals the x-coordinate of the vertex, so it's x equals 15. Max or min value, we look at the concavity. The a value is positive because remember, a works exactly the same way whether it's standard form or vertex form. We don't need to do anything new as far as the concavity goes. We just look at the sign of the a value. Since a is positive, we think positive. That's happy, smiley face, which puts the vertex down there, which means it's a minimum value of negative 107. Negative 107, we've got that from the y value of the vertex. Okay, now we need our domain. That's easy for quadratics. It's from negative infinity to positive infinity, or you could say all real numbers. Now the range we actually have to think about. So there's a minimum value, which means we're starting low and going up forever, which means we have to start at negative 107. And since we're going up forever, it's going until we get to, or going to infinity. Infinity is not a number. We're never going to get there. Let's check our answers. 15, negative 107. Good, 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 and good. Excellent. Let's keep on rolling. Look at number 10. This equation looks like it's in standard form, so we can write standard form to remind us what that is. Ax squared plus bx plus c. I guess technically I should have the y equals in front. I see an a value of negative 17. I see a c value of 111, and there's no b value, which essentially means that b equals 0. So I'm going to write that there just so I don't forget about that. All right, to find the vertex for standard form, we know we have to use negative b over 2a to find the x-coordinate. Plug in, so that becomes negative 0, which is really just 0, divided by 2 times negative 17. And then we get 0 over a negative, I think that's a 34, but that's just going to come out to 0. 0 divided by almost any number would be 0. The only exception if it was 0 divided by 0, but we know we can't divide by 0, so we'll just skip all that. So we know that's the x-coordinate, so it's going to be 0 something. We don't need this work anymore. Now we just plug in our x value to find the y value. So this becomes y equals negative 17 times 0 squared plus 111. Well, let's think 0 squared is 0 times negative 17 is still 0. So all this pretty much cancels out. We're just left with 111. Vertex is done. Axis of symmetry, well, we know that's x equals 0, just getting that from the x coordinate of the vertex. Max or min, I like to think about concavity first. The a value is negative. We think, oh, negative, that's sad, that's a frowny face, so it's concave down. Vertex is up here, which means this parabola will have a maximum value, and the maximum value will be 111. Just taking that from the y coordinate of the vertex, like always. Scrolling down domain, we know that's always the same for a quadratic, going from negative infinity to positive infinity. Range, we have to look at the max or min value. It was a max value, so we're starting at a number and going down. So we're going to go down forever. So that means essentially we're going from negative infinity to, what was the max value? 111. 111. And then we finish that bracket and check our answers. Let's see, vertex is good, axis symmetry maximum. Right, so far so good. Let's keep on going. Now our number 11, change of directions here. It says write a function rule to represent each graph. So here we've got a graph, and we have to remember a function rule is essentially an equation. So they're actually giving us a choice here. We can write it in standard form or vertex form. If we've got the option, I think vertex form is going to be a lot easier. So that's the way I'm going to do this. Where do I want to show my work? I guess we'll do it right here. So we'll start with y equals a times x minus h squared plus k. I guess I'll scroll it down slightly. There we go. Let me see. They give us 2 points. This point's going to be the point we're going to start with because that's the vertex. That's a -1 and a -2. So that's our h and k. We can plug that right in. So this becomes y equals a times x minus the -1 will be +1. Just plugging in that h and k. I guess I'll write that here just in case that's helpful for anyone. And then plus k. Oh, forgot my power of 2. Don't forget your squared. Your squared is the most important part of the function. You need that power of 2. Otherwise, it's not even a quadratic. So a lot of students think, oh, we forgot the power of 2. That's not a big deal. You really, really need that power of 2. And where was I plugging in k? So, oh, that's not going to be a plus anymore. That's a -2. So a lot of this is already done. Now we just have to find a. Well, we're done with the vertex, so now we have to use this point that they're giving us. So that ordered pair is 2 then 1, x value of 2, y value of 1. Now remember, anytime we have an x and a y, anytime we have a point that's an x and a y, we can plug in. And that's exactly what we're going to do. So this equation turns into 1 equals a times our x value is 2 plus 1 squared minus 2. Now this is an equation with one variable. So we can just simplify and solve, and that's exactly what we're going to do. This becomes 1 equals a times 2 plus 1 is 3 squared minus 2. I'm going to show all my work here, even though a lot of you can probably skip some of these steps in your head. 3 squared is 9. I'm going to make my 9 and a obviously different. Minus 2. Add 2 to both sides. We get 3 equals 9a. Divide everything by 9. That's a little weird. And that comes out to 1/3 if I'm doing that correctly in my head. So 1/3 equals a. Now we just take that and plug that into our equation, and we get our final answer of y equals 1/3 times x plus 1 squared minus 2. Hopefully that's what I have here. 1/3 x plus 1 squared minus 2. Yep, so far so good. Let's keep on going. Number 12, same direction, so we approach it the same way. It does not specify whether it's vertex form or standard form, so I'm going to use vertex form because that's, at least to me, easier to work with. So it's y equals a times x minus h squared plus k. Find our vertex, which is right here. Let's see, that's -1, 2, 3, 4, 5, -6 for the x coordinate. And then the y coordinate is 1, 2, 3, 4, 5. So -6, 5. And that's our h and k. Plug it right in. So actually, I'm going to plug this right here for the final answer. So it's going to be y equals whatever a is times x plus 6 squared. And what's k? Plus 5. And now let's plug this in down here as well, because we still have some work to do with this equation, because we still have to find a. Hopefully remember, just like the last problem, they're giving us another ordered pair. So we can use that those xy values to plug in and find the last variable, find a. So what is this? Let's see, that's -2 for an x value, and -1, 2, 3, 4, if I'm counting that correctly. Hopefully I am. Of course, it all disappears. What was that? -2, -4. Let me count that in a different color. 1, 2, 1, 2, 3, 4. Good. Now we plug it in. Y becomes negative 4 equals a times x becomes negative 2 plus 6 squared plus 5. Now that we just have one variable remaining, we simplify and solve. Negative 4 equals a times negative 2 plus 6 is 4 squared plus 5. Negative 4 equals 4 squared is 16, so it's 16a plus 5. Then it's a two-step equation. We just subtract 5 from both sides, get negative 9 equals 16a, divide by 16. Can we simplify that? No, no common factors. So that's our a value, negative 9 over 16. So we plug it back in. Negative 9 over 16. Let's make that a little bit easier to read. And hopefully that's the answer we have here. Negative 9 over 16 times x plus 6 squared plus 5. All right. Moving on to number 13. Moving on to number 13. Oh, now I know why the numbers don't match up. Whatever. We don't care about that. Okay. Determine a and k so the given points are on the graph of the function. Let me see here. Okay, so they're giving us an equation, f of x equals a times x minus 7 squared plus k. And we actually don't have to write the equation. They're just asking us for a and k. So I'm going to write a equals and k equals just to help remind myself that that's what we're looking for. We just need two numbers here, not an equation. Now let's see what they're giving us to work with. They're giving us two coordinates, which hopefully immediately we're thinking, oh, that's an x and y. Both of these are an x we can plug in and a y, an ordered pair essentially. So let's plug in the first one and see what happens. So we're plugging in 5, 7. F of x, that's the same thing as y equals. So instead of f of x, we can put 7 equals then a, we don't know, times, instead of x, we write 5. And then we put minus 7 squared, and we don't know k, so it's plus k. Let's simplify this at least as much as we can. 7 equals a times 5 minus 7 is negative 2 squared plus k. And this becomes 7 equals negative 2 squared is positive 4a plus k. And that's as far as we can go because we've got one equation with two variables. But if you remember from earlier in this year, if we have two variables, one way to solve for those two variables is to have two equations. And we've used one x and y values, one ordered pair to plug in, but we still have another one that I'll do in green just to help this work, keep us organized, I guess I'll say. So we plug it in to this equation. Instead of f of x, which is essentially y, we write 23 equals a times, instead of x, we write 13 minus 7 squared plus k. Now we've got some simplifying to do. We get 23 equals a times 13 minus 7, that's 6 squared plus k. We get 23 equals 36a plus k. And that's as far as we can go. But fortunately, we've got two equations with the same two variables, with a and k. So essentially, we have a system we can solve by, I guess we could graph it if we really wanted to, but I think solving by substitution or elimination. I guess I'll keep writing in red since this is the next step. I think elimination is going to be easier because we've got the a's and k's both sort of in the same position. So we want either the coefficient of a or k to be the same number but a different sign, opposites essentially. And these k's look like a prime contender because they're both a plus k. So all I have to do is multiply one of them by a negative 1. I'll multiply the blue one by negative 1. It doesn't really make a difference. Then the blue one becomes negative 7 equals negative 4a, almost forgot to distribute, minus k. And the green one stays the same, so I'll write it right under it. 23 equals 36a plus k. Scroll down. Now, if we combine these two equations, the k's will cancel out. They'll go away. So we'll only have one variable. So let's see, 23 take away 7, that's going to be 16 if I'm doing that correct in my head. I think I am. Equals 32a. Yep, looks good. Divide by 32. And I think that's 1/2, right? Yeah, a equals 1/2. So we are halfway to our answer. Because remember, all we needed to find here was a and k. So a equals 1/2. And now we can take that and plug it in to find k. Let's see. We can plug it into any of the equations. I think this one's going to be the easiest to work with. So we'll rewrite the blue. So it's 7 equals 4 times, we can write this in red just to color code it, 1/2. A colorblind teacher color coding. What could go wrong? And I lost my place, plus k. 7 equals 4a plus k, a equals 1/2. All right, now, again, this is algebra 1 stuff. We get 7 equals 4 times 1/2 is 2, plus k, take away 2, and we get 5 equals k. Drag this screen back up, plug it in, check our answers. 1/2 and 5 looks good. Moving along. Same directions, we got to determine a and k, so we're going to approach this the same way. We're going to use this equation, plug in the x and y values they give us, and see, we're probably going to need a system just like the last one. So we'll do this one, we'll do the blue, it's -6 and 11. So the equation becomes y, which is 11, equals a times x is -6, plus 11 squared plus k. Simplify as far as we can go. We get 11 equals a times 5 squared plus k. 11 equals 5 squared is 25, a plus k. And then, oh, that's as far as we can go. There's no more like terms. I mean, we could move the k over, but there's no point because we've got one equation with 2 variables. That means one way to solve this would be a second equation. Unfortunately, they're giving us a second order pair, a second x and y that we can plug in. Oh, I forgot to put a equals and k equals, just to remind myself that that's what we're looking for, determine a and k. All right, back to the green equation. What is it? Oh, not y equals, because y is 41. That's the whole point. We're plugging in the x and y values. So we get 41 equals a times x becomes -21 plus 11 squared plus k. Now we simplify as far as we can go. 41 equals, that's going to be a times -10 squared plus k. Then we get 41 equals -10 squared is positive 100, a plus k, and that's as far as we can go with that equation. And now we've got a system, 2 equations with the same 2 variables. I'm going to eliminate k again just by multiplying this one by -1, just to change those signs. The blue one would then be a -11. I'm going to do this slowly so I don't forget to distribute. -25a minus k. The green one doesn't change, so it's 41 equals 100a plus k. And now that we have a plus k and a negative k, they're going to cancel out when we combine. Let me think here. This is going to be a positive 30 equals 75a. Divide 75 on both sides. So we get 30 over 75. Let's simplify this. We can divide them both by 5, so that would be 6 over 5 goes into 75 15 times, if I'm doing that correctly in my head. I think I am. And then we can divide that still by 3 each, so we get 2 over 5. Is that the same thing? I'm going to double check myself because I really don't feel like screwing this video up. So I need to check that 30 divided by 75. We need to make sure that equals the same thing as 2 over 5.4, and it does. Excellent. Very good. So what was that? Oh, that was all defined a. So that equals a. So we can actually bring that up as 1/2 of our final answer. Now we just have to find k. So we're going to plug in a to do that. So the green equation, oh, do I want to use the green one or the blue one? I guess it doesn't really make a difference. I'll use the green one just because I think I used the blue one last time, just to show that you can do it either way. We get 41 equals 100 times, and this is where we plug in our a value. I already forgot what it was. It's 2/5. So 2 over 5. Oh, I meant to do that in red, didn't I? Yeah, trying to color code this. 2 over 5 times, well, we just close the parentheses, then put plus k. Now we solve for k. Still in green. So we get 41 equals, you could do this a few ways. You could do 100 times 2, which is 200. Divide that by 5, that's 40. Am I doing that correctly in my head? 40 plus k. I'm going to double check myself with our cross canceling. So if we cross cancel, the 100 and the 5, we can both divide by 5. So that'd be a 1. 5 goes into 100 20 times, and then 20 times 2 would be 40. Yeah, so now I'm pretty sure I did that correctly. Then we take away 40 from both sides, and we get 1 equals k. Bring that up as our final answer. Then we check it with the answer key. 2/5 and 1. All right. Number 15. Write a standard form equation for a quadratic function that has a vertex of 338 and a y-intercept of 11. So this is another problem where we have to write an equation, but here they're specifying it must be in standard form. So I'm going to write standard form. So it's y equals ax squared plus bx plus c. Now we need to find three numbers here before we can write our answer. We need to find a, b, and c. And let's look at the clues they're giving us. They're giving us the vertex, which is 338, and they're giving us the y-intercept of 11. We're going to need both of these clues to complete this problem. I would actually start with the y-intercept because remember, one of the big advantages of standard form is that c is always the y-intercept. So right away, we can just put y equals. Tell you what, I'm going to leave some space here for my final answer. We know c will be plus 11. Right, so now we just have to find a and b. So let's think. Let's make this y equals ax squared plus bx plus 11. Because remember, I'm just leaving this blank right there for the final answer, so I know I've got space. Below that, we're going to sort of keep going with our work. So we plugged in c, which is 11. What else can we do here? Well, they're giving us a point. They're giving us an x and y. So remember, anytime we see an ordered pair, we got to think, oh, that's an x and a y value. We can plug in. So y becomes 38 equals a times x is 3 squared plus b times x, again, is 3 plus 11. Let's see. I'm going to show all my work here. If you can do some of this in your head, that's great. I just don't want to lose anyone in the video. So we get 38 equals 3 squared is 9a plus 3b plus 11. And we've got two variables here, so we're not going to be able to solve this completely. But, I mean, we can at least subtract 11, I guess, just to make this somewhat nice, or nicer, I guess. 38 take away 11, that's 27, equals 9a plus 3b. Okay. At this point, we're stuck because one equation, two variables. That means one way to do this would find another equation. But I was just about to say we've used all the clues they've given us, but that's sort of not true. The one thing we have not used yet is the fact that 338 is not just any old x and y ordered pair. It's the vertex. And whenever you're in standard form or working in standard form, you need to always have negative b over 2a right here in the front of your mind. Negative b over 2a equals something. Now, one common mistake students make is like they try and plug in b or a, but we don't know b or a right now. That's the whole point. We're trying to find b and a. So there's nothing we can plug in right here. But we know what negative b over 2a will equal because negative b over 2a is the x-coordinate of the vertex. It's the x of the vertex. And we know that. The vertex is 338, so negative b over 2a is going to equal 3. So this is another equation with a and b. Now we're just gonna manipulate this a little bit more because I don't like having this fraction here sort of screwing everything up. There's a few ways to do this. I would multiply by 2a on both sides just to get rid of the denominator. That becomes negative b equals 6a. And then honestly, I would get rid of this negative right there. So I would divide by negative 1, and we get b equals negative 6a. I guess you could have actually done that faster in this first step if you multiplied by negative 2a, because negative times a negative would have become a positive. So that would have saved us some time, but it doesn't matter. We're still working toward our answer. Okay, so we have two equations, equation 1, equation 2, and I would not use elimination this time because the b's and the a's aren't really lined up. I would just use substitution because we know b equals negative 6a. So wherever we see b, we can substitute in a negative 6a, and that's exactly what we're going to do. So this equation becomes 27 equals 9a plus 3 times not b anymore because we know b is negative 6a. And now we have one equation with, I know there's technically two variables, but they're the same variable. They're both a. So we can solve. Let's get rid of those. Come on. All right. What are we doing? Right. So 27 equals 9a. Let's see. 3 times negative 6 is going to be negative 18a. Then we combine our like terms, get 27 equals, that's negative 9a. Then we can divide both sides by negative 9. and we end up with a -3 equals a. And we can take that and plug it right into where our final answer is going to be. So it's -3x squared plus or minus something with x, because we don't know b, plus 11. And to find b, we can actually just take this a value and I would plug it in right there. I think that'd be the easiest way to find b. Not the only way, but the easiest in my opinion. So this becomes b equals -6 times what was a? -3. And we get b equals 18. And we can plug that in, so it becomes a plus 18, and we are finished. That's our answer. Let's check it against the answer key. Fingers crossed. -3x squared plus 18x plus 11. Excellent. Let's keep on rolling. Number 16. Similar directions, but not the same. Let's see. A quadratic function has a vertex at the point 5, -6, and can be represented by the equation y equals ax squared plus bx plus 1. Okay, that's obviously going to be important, so I'm writing that down right now. Ax squared plus bx plus 1. All right, essentially that's standard form, but they already gave us the c value. We have to determine the value of a and b. Oh, so we don't need an equation here. It's just a equals and b equals. That's what we're looking for here. So I'll put a box right there for the answers. I guess I won't put the box there, but I'll just put a line sort of separating it. Whatever. Okay. What clues are they giving us? We already wrote down the equation, so that's good. Oh, they're giving us a 0.5, -6, so that's an x and a y. And it's also the vertex. Oh, so this is basically the same thing as number 15, the last one we just did. Let's first plug in x and y. So y, we get -6 equals a, not x anymore because it's 5 squared, plus b times, not x because we're substituting in 5, erase that slightly, plus 1. Now what's even worse? There we go. Okay, we can simplify this. We get -6 equals 25a plus 5b plus 1, subtract 1, -7 equals 25a plus 5b. All right, so far so good. That's as far as we can go with that equation, but we have not yet used the fact that this 0.5 -6 is the vertex. Since we're working in standard form, we know -b over 2a is going to equal whatever the x-coordinate of the vertex is, and that's going to be 5, right there. Again, we can't do that with any old point. We can only do that with the vertex. It was 5, right? Good. That's what I get for trying to talk and write at the same time. All right. Let's draw a line to separate these two equations. We need to get, well, again, I just don't like this 2a in the denominator, and I also don't like the negative. So I actually am going to do this all in one step this time. I'm going to multiply by a -2a on both sides. Because negative, let me sort of show what I'm doing here. The negative times a negative will become positive, and the 2a, the times 2a will cancel out with the dividing by 2a. So all we'll be left with on the left side is a positive b. And on the left side we get, or excuse me, on the right side rather, we get -10a. Now we're ready to substitute, just like we did in the last problem. We can erase that. So this equation all the way on the left becomes -7 equals 25a plus 5 times, not b anymore, because b equals -10a. So I plug in -10a for b, and we simplify. Let me draw this line right there, separate my work. What are we doing here? So it's -7 equals 25a minus 50a, and then we just combine like terms and divide. -7 equals -25a. Divide everything by -25. And we get 7 over 25 when the negatives cancel out equals a. That's not going to simplify any further, so we found our a value, 7 over 25. We double check that number one more time, 7 over 25. Good. Now we just have to find b, and just like last time, we're going to plug in or substitute in for that a. So this equation turns into b equals -10 times 7 over 25. Oh, this is a fraction, so tell you what, I'm going to write the -10 as a fraction times 7 over 25. Again, you could just do this in a calculator. At least me just doing it mentally, it's easier to look for cross-canceling. The -10 and the 25 are both divisible by 5. -10 divided by 5 is a -2. 25 divided by 5 is a 5. And then we get b equals numerator times numerator. -2 times 7 is -14 over denominator times denominator. 1 times 5 is 5. So -14 fifths. -14 over 5. Check the answer key. 7 over 25, negative 14 over 5. Excellent. Okay, now big gear shift here. So it says, for what values of x will f of x be? And number 17 is positive. So these ones, it's still algebra, but it's very conceptual. It's very visual. At least that's the way I think of it. So we're looking for so when f of x, when the y values, when the range values will be positive. Well, the positive y values are all here, and the negative y values are all down there. So essentially, positive means when are we above the x-axis? That's where all the positive y values are. So here's the way I think about these problems. I look at this graph and I think, okay, where is this graph positive? Well, it's positive when it's above the x-axis. So these are all the parts of the graph when it's positive, because that's the only part of the graph that's above the x-axis. Now, we're going to need two things here. We need an inequality and a graph. You can do either first. I actually think it's easier to do the graph first. Let me see. So we need to know where our dots are going to go. So essentially, it's starting being positive just after 2, and it ends being positive just before 8. Because at 2 and 8, f of x is neither positive or negative. It's 0. It's right on the x-axis. So that means we need an open dot on positive 2 and an open dot on positive 8. And then I just think, okay, where's the shading? Well, the shading, I'll do this in a different color to make it stand out, is right there. The shading's in between the two of them. So that's what I shade. I shade in between. And then from there, I write the inequality. This is an and compound inequality because the shading is meeting in the middle. So I'm going to write this as 2 must be less than x must be less than 8. Essentially saying, this essentially means x is in between 2 and 8. And we check the answer key. Looks good. All right. Number 18. Very similar directions. Oh, that's not what I meant to do. That's what I meant to do. Very similar directions, but now we want the values of x for that will make f of x negative. So we ask ourselves essentially the same question. When is f of x negative? And instead of being above the x-axis, we want it to be below the x-axis because that's where the negative y values are. So let's see. What part of this graph is below the x-axis? I see this part is below the x-axis, and I see this part is also below the x-axis. So here we actually have two shaded parts of the graph. Again, starting at 2 and 8, so we can put our open dot on 2 and open dot on 8. And then this section is sort of shaded to the left of 2. So that's exactly what we're going to do. We're going to shade this way. And this part is essentially shaded to the right of positive 8. So that's what we do on our number line. We shade to the right, and there we go. So since the shading is going two different directions, this will not be an and compound inequality. This is an or. So we need to write two inequalities here. So we've got x is less than 2, or x is greater than 8. Check the answer key. Less than 2, greater than 8. Shading looks good. All right. Number 19. For what values of x will f of x be increasing? So this is a big shift. We're not talking about positive or negative anymore. We're talking about increasing. Now, whenever I'm talking about increasing or decreasing, I know this is stupid, but I always imagine my graph like it's a roller coaster ride. So I think, okay, I've got my roller coaster car, and the roller coaster car always goes from left to right across the graph. So we're going left to right. Okay, so here we finally catch up to the roller coaster. And what are we doing right now? We're going up. We're increasing, getting higher, increasing, till there. So this is the point where we stopped increasing and then we started decreasing. We're going down. So increasing, stopped, and then we're decreasing. And the reason that's so important is because this tells us where to put our dot on the graph. It's right there at 5. That's the x value. So I put my open dot on 5 right there, and then it was increasing on this side. It was getting higher and higher until it got to the peak of the roller coaster. So it's shaded to the left. So we shade to the left because that's what we see in the graph. Kind of easier than the last one because there's no compound inequality. It's just one inequality. It's just x is less than 5. Check the answer key. All right, so far so good. Away we go. Very similar to the last one, but now it's saying decreasing instead of increasing. So again, I imagine my roller coaster car. Okay, we're starting here, moving from left to right. Oh, it's increasing until there. Then we start decreasing. So this was the part of the graph when we were decreasing. So we need an open dot on, what is that, on 5, open dot on 5, because that's the x value when we started decreasing, and we're shading to the right because this shading right here is to the right of the x value of 5, essentially to the right of the vertex. Because really the vertex is what separates the increasing and decreasing parts of a parabola. Now we just need the inequality. It's x is greater than 5, and that should be it. X is greater than 5, and the shading looks good. All right, moving right along. Number 21. Different graph, but similar problem for what domain values. Okay, so don't get thrown off by this. Domain values just means x values. Same thing. For what domain values will g of x be increasing? Okay, it's increasing, so I imagine it like it's a roller coaster going left to right. Now let's get rid of that. So going left to right, okay, oh, we're decreasing, getting lower and lower and lower until here, this point, then we finally start increasing, and we're increasing for the rest of the roller coaster ride. Now we just have to take that representation and put it on our number line. We need an open dot on, what is this? On -3, open dot on -3, and it's shaded to the right. And there we go. Writing the inequality, it's x is greater than -3. Check the answer. Greater than -3, shading looks good, excellent. 22. Same graph, but now it's decreasing again. Think of it like a roller coaster ride. We're decreasing right off the bat all the way until there, then we start increasing. So this was the part of the roller coaster ride when we were decreasing. We were getting lower as we went from left to right. So we need an open dot, that's still -3, right? Yep, still on -3, which is right there. And we're shading to the left. And the inequality would be x is less than -3, and that should be what we have here. -3, shaded to the left, less than, excellent, very good. Number 23, okay, now we're worried about positive or negative. We're worried about above the x-axis or below the x-axis. So I look at my graph, we want it to be negative here. So we have to shade all the parts of the graph that are below the x-axis. So that would be everything right there. This is the only part of the graph that's below the x-axis. It starts there, ends there. So what are those numbers? That's a -7, open dot on -7, and a +1. And the shading is in between those 2 points. Shade in the middle. And since the shading is in the middle, it's a compound inequality and compound inequality. So we start with -7, our lower bound, and x is going to be less than, what is that, 1 is the upper bound. And that should be it, hopefully. -7, less than x, less than 1. And the shading's in between -7, go away, -7 and 1. Excellent. All right. New graph. Oh, wait, no, same graph, right? Oh, new question. Okay, now it's positive instead of negative. Okay, so now we want everything that's above the x-axis. So this part's above the x-axis, and this part of g of x is above the x-axis. So starting there and there. So here the shading's not meeting in the middle. It's going in 2 different directions. So from -7, it goes to the left, and from +1, it goes to the right. And this is going to be an or compound inequality because it's going 2 separate directions. So it's x is less than -7 or x is greater than 1. Check the answer. Less than -7 or greater than 1. Shading going 2 different directions. Good, good, good. Okay, for what x values will h of x be positive? So still thinking above the x-axis because that's what positive means. And I don't see any part of the graph that's above the x-axis. So, I mean, this is kind of awkward, but for what x values will h of x be positive? None. There's no x values. And so we don't even shade anything. That's it. We're done. Yeah, none. And there's no shading at all because there's no x values that fulfill these requirements. Number 26, same graph, but now it's asking for what x values will h of x be negative. Now we're thinking below the x-axis. And let's see, this part's below the x-axis, and that part's below the x-axis, so all of it's below the x-axis. So we don't really need an inequality. I would just say all reals or all real numbers, and I'd shade the whole thing in both directions. Hopefully that's what the answer key says, all reals and shaded everywhere. All right. Same graph, but now it's asking increasing. So we go to our roller coaster ride, going from left to right. Oh, it starts out increasing up until there. and then it starts decreasing. So that's the part that's shaded right there. That's when it's increasing. So let's see, the x value is -8. That's when it stops increasing, and it's shaded to the left. So as an inequality, that would be x is less than -8. Check the answer key. Less than -8, shaded. Very good. Number 28, decreasing. Very similar to the last one. We imagine it like a roller coaster ride. Don't do that. There we go. Left to right, increasing, increasing. Oh, we reached the peak, and now we're decreasing. So it was decreasing on the right side of that x value of -8. So a open dot on -8, shade to the right, because that's when the roller coaster ride was decreasing. Let's not forget the inequality. X is going to be greater than -8, because shading to the right means greater than, or x is greater than. X is greater than -8. Shading looks good to me. All right. All right, now we're in the home stretch. Last topic, average rate of change. So it says a quadratic function is shown in the graph below. Use the graph to find the average rate of change of the function from x equals -1 to x equals 3. Now remember, with average rate of change, it's just like slope. So essentially we're thinking rise over run. But since the rise over run is changing for this, since it's a curve, they need to give us the specific starting and ending points. That's where x equals -1 and x equals 3 come in. So let's see, x equals -1 is right here. So if we go up there, this is going to be our starting point right there at 2. And x equals 3 is right here. Oh, and that's right there at 0. That's not too bad. Now the next thing we have to be really careful about is the scale, what we're going up by. So first is rise, so we're going to worry about our vertical change, the change in the y, the change in, what is this, g of x, h of x? Oh, it doesn't even say, so the change in y, we'll just call it. Oh, and the y's are not going up by 1. The y's are not going up by 1, because 1 is right there. That's 2 steps essentially, so 1 step would be a half, so it's like we're going up by 0.5. So we have to keep that in mind as we count. We're going up by 0.5 for the y's. I guess I'll keep that right there. Oh, it's good. Let's do this in green so it stands out. So we're going down 0.5, 1, 1.5, 2. So that's a -2 since we went down 2. And the x scale looks good. The x scale is going 1, 2, 3, 4. So that's no problem. So we can just count that like normal. Let's go back to green. 1, 2, 3, 4. So it's -2 for the rise and 4 for the run, and we simplify that. That's just -1/2. That should be our answer. Check it against the answer key. Excellent. Same graph, but different starting and ending points. So even though it's the same graph, we can't just automatically say, oh, the average rate of change is going to be the same, because it's not. We're starting from 1 and going to 5. So x equals 1 is right here. So that's our first point. And the second point is x equals 5. So we go to 5, go up to the function. So this is the ending point. And we do our rise over run. Oh, and we got to be careful with the scale as well, because remember, this y value was going up by, or rather the y-axis was going up by 0.5. So we got to keep that in mind. Actually, that doesn't matter this time, because the rise is 0. We don't go up or down at all. And the run is, we'll do this in green, 1, 2, 3, 4. So it's 0 over 4, which is just 0. Yeah, the answer is 0, which you might have been able to tell just by seeing that the height of this point was the exact same as the height of that point. But if you ever don't see that shortcut and you do rise over run, you'll still get the same answer. It'll take you a little longer, but there's nothing wrong with that. Okay. Still the same graph, still the same question, just different starting and ending points. So going from x equals 3 to x equals 5. So x equals 3 is right here. And the point's right there, and x equals 5. Oh, that's not what I meant to happen. Whatever. And then x equals 5 is right there. So that's our ending point. And here we do have to be careful of the scale, because we're going up 1 step, but remember, that's 0.5. So the rise is, oh, let's write rise over run. I'm being sloppy. Rise over run. So the rise was 0.5 over, and the run was 1, 2 steps, and the x scale was good, so that's just 2. But we don't want to leave it like this. We don't want a decimal here in our fraction. So 0.5, how can we make that a whole number? Well, we could just double it, like multiply it by 2. I guess I'll use parentheses. And anything we do to the numerator, we have to do to the denominator as well. So 0.5 times 2 becomes 1. 2 times 2 becomes 4, so 1/4. All right. Got the same answer as the answer key. That's always a good thing. Number 32. Just got 1, 2, 3, 4, 5 more to go. Almost there. I can see the light at the end of the tunnel for this video. Where am I? So find the average rate of change. Okay, so basically the same type of problem. Even though this is not a quadratic, it's not a parabola, we just still approach it the same way. So we're going from negative 12 to 8. So negative 12 is right there, which means that's our starting point. 8 is right here, meaning this is our ending point. But let's check our scale. Before we actually calculate rise over run, let's check the scale. Make sure they're not trying to trick us here. The y looks okay. 1, 2, 3, 4. Yep, that's good. Let's check the x. 1, 2. Oh, no. Because that's 2 steps, and it's going to 4, so that'd be going up by 2s, I guess. So it's 2, 4, 6, 8. Yeah, we're going up by 2s. So we got to remember that's a negative, that's a 2, and that's a negative 2. So for anytime we're using this graph, which I think is 3 more problems, we have to remember that anytime we're calculating the change in x, the run, we're going up by 2s. I'm really just saying that so I'll remember, to be honest with you. All right, so rise, we can do this in green, I guess. So we're going down 1, 2, 3. So that's a negative 3. And the run, here's where we have to be careful. We're going up by 2s. So let's think 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So negative 3 over 20. Does that make sense? Yeah, that makes sense. I don't even think that's simplifiable. Just negative 3 over 20. Yep, we're done. Excellent. All right, same graph, 2 new starting points. So x equals 0, which is right here. So that means that's our starting point on the function, which is g of x. And 10 is the ending point. Oh, these are going up by 2. So 4, 6, 8, 10 would be right there. That's the ending point. Calculate our rise over run, because average rate of change is just a fancy way of saying, give me the slope, the rise over run from this point to that point. Let's see, rise, we're going down to 1, 2, because the y scale was just by 1, so that's a negative 2. We can put that right there. Negative 2 over the x scale we need to be careful of, though, because that's going up by 2. So 2, 4, 6, 8, 10, if I counted that correctly. I'm going to double check myself. Yeah, it looks good. So negative 2 over 10, we can simplify that to a negative 1/5. Is that the answer? If I move my face out of the way, negative 1/5 it is. All right. That's what I meant to happen. There we go. Number 34. Let's find our starting and ending point, because it's still an average rate of change problem. X is negative 14 is where we're starting. So, oh yeah, we're going up by 2. So negative 8, 10, 12, 14 is right there. Starting point is there on the function g of x. Ending point is 18. So let's think 12, 14, 16, 18. That means that's our ending point for the function. Still doing rise over run. And let's think. The rise, I think it's just up 1. Up 1, would that do it? Let me double check this in blue, because now we're on the same line. Yeah, so it's just a rise of 1, excuse me, over the run. Here we're going up by 2, so there's going to be a lot of counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Let me double check that. I think I counted that correctly. Yeah, I'm pretty sure that's right. Oh, we can't even simplify it. Just 1 over 32? 1 over 32? All right, very good. Just 2 more to go. These are still average rate of change problems, but there's a very big difference between this and the last few we were doing. Here, there's no graph. So it can make it more difficult to find the rise over run. So instead of using rise over run, I'm going to use slope formula, which, if we remember, is y2 minus y1 over x2 minus x1. That's how we can find the slope, as long as we have a starting point and an ending point. Well, we see the starting and ending x values, but we don't have the starting and ending y values. That's where the function rule comes in. That's where the equation they give us comes in. So all we're going to do is take the x values, plug them in, and see what y values we get out. So the first x value is 0, so it's going to be f of 0 equals 0 squared. I guess I could put parentheses around that. It doesn't really matter. Plus 0 minus 3. And let's think. 0 squared is 0 plus 0 is 0, so we just get negative 3. So that means this coordinate is 0 for the x and negative 3 for the y. I'm going to make that our x1 and our y1. Now we're going to do the same thing for 4. So instead of f of x, it's f of 4. Again, just getting this right from our starting and ending x values. So f of 4 equals, and just copy it right from there. Instead of x squared, we put 4 squared plus 4 instead of x minus 3. Then we simplify. I'm actually going to do my work down here just so I can have the 2 points written right next to each other. I guess it doesn't make that big of a difference. So 4 squared is 16 plus 4 minus 3. That's 20. Take away 3 is 17 if I'm doing that correctly in my head. I think I am. Yeah, good. So at this point, the x value was 4. That's what we plugged in, and what we got out was a 17. I'm going to make that our x2 and our y2. Now all we have to do is take that and plug it in to the equation. Plug it into the slope formula, which I guess is sort of an equation, but never mind. We don't need to talk about all that. Okay, so y2 is 17 minus y1. Oh, that's minus a negative 3, so it's going to be a plus 3 over x2, which is 4, minus x1 is 0. And again, just stealing these right from the 2 points we found, the two x, y coordinates. 7 plus 3 is 20 over 4 minus 0 is 4. So we end up with an answer of 5. Check the answer key. Excellent. Last one, final, last problem for this review. Just same directions as number 35. Find the average rate of change of, this time they give us a new equation, or a new function rule, I should say. H of x equals x squared minus 5x minus 4 from x equals negative 1 to x equals 5. Since there's no graph here, I'm going to use the slope formula, y2 minus y1 over x2 minus x1. Because remember, that's all rate of change is. It's just slope. And average rate of change is just the slope from one point to another. Where are we? So we know what our x values are, but we need to find the y values. So whenever we have an x value, we just plug it in to find the y. So h of, let's use negative 1 first. That's our starting point. So h of negative 1 equals negative 1 squared minus 5 times negative 1. Let's make that 5 look a little bit better. Minus 4. Double check that. Make sure I didn't screw up any signs. So far, so good. Then this would become negative 1 squared is positive 1 plus 5 because it's negative times negative becomes positive minus 4. And let me think. That's going to be a 2 if I'm doing that correct in my head. 1 plus 5 is 6. Take away 4 is 2. So the x value we plugged in was a negative 1. The y value we got out was a 2. That's going to be my x1 and y1 when we plug into the slope formula. Then we get h of, what was the ending point? 5, right there. So it's h of 5 equals, oh, I need to see my equation. Looking right there. So it's x squared, so that becomes 5 squared. That's our domain value, the input value we're plugging in, that 5. 5 squared minus 5 times x becomes 5, because that's what we're plugging in, minus 4. Scroll down, so we have some more space to work. 5 squared is 25, minus, well, 5 times 5 is 25, minus 4. So 25 take away 25 is 0, minus 4, so we just get negative 4. Which makes the second point 5, or the x value is 5, and the y value is negative 4. So I'm going to make that my, I guess I can fit it here, x2 and y2. Now we scroll up and just take those numbers and plug them in to our slope formula. y2 was negative 4, minus y1 is 2, all divided by x2, which is 5, minus x1, which is negative 1, minus a negative becomes a positive. Negative 4 minus 2 is negative 6 over 5 plus 1 is 6. So we end up with a negative 1. Cross your fingers, check the answer key. Negative 1. Excellent. All right, so hopefully this video was helpful. We're finally done with this review. By all means, if you have any questions, let me know. Good luck studying for the quiz. Enjoy the rest of your day.